interact operation and drilling a new well. Another way, we can use a casing with the lower size that cover the internal diameter of the casing. But also for this operation, we have a limitation due to tubing size and compilation storing size.
And you suggest?
Or maybe first, side track operation. Second, casing with a smaller size. Second solution, cement squeezing operation. Cement squeezing means that inject a cement with a special chemical characteristic to cover the casing interval damage.
Here the question is, how can we inject the chemical or the cement in this kind of area?
This kind of area?
Yeah, this area, how can we inject it?
To damage area.
To damage.
Yeah, to damage.
For this type, this is the casing. Suppose that this interval damage, okay? At the first, set a plug. The name of this plug is bridge plug, okay? At the second part, run a perforation tools and perforate this type. This is the artificial damaging by the drilling supervisor. After that, remove the perforation tools and inject a cement through a drilling pipe and cover all of these, and all of this interval full by the cement. Another operation, another sequence. Drilling this cement with the smaller bit. Like this.
With the
So, this damaged casing
to be
secure.
Secure, and then after that we will, how can we, we remove this plug.
This plug,
Yes.
we have a different type of the plug. Some of mechanical, some of the hydraulic.
So it's same like butter.
Same like the packer. But in the many operation, it is a permanent plug. Also, this is drillable and drill and back to the surface. So the casing is secure. Cement squeeze. This is the mitigation process for the cementing, for the casing failure. But this is the remedial action.
Yeah, this is the last choice. It's cheaper, I guess. And
It's the cheaper,
yeah, it's better.
but it's not effective at any time. This is based on the type of the damage. Maybe we have a basic damage, and all of the casing burst, or all of the casing collapsed. This is not useful. The best way is side tracking, but it's very costly.
It is.
It consumes any cost and the time. Casing with the lower diameter, it's a good choice, but it has a limitation due to tubing size and compilation size. This is the best, but it's not a good way for any type of the casing damage. This is the way to solve the casing problem, but the source of the casing problem
Yes.
source of the the casing problem. One way, one of the problem that causes the casing problem, channeling of the water behind the casing. Water channel from some of the formation and touch with the casing and create a corrosion and damage the casing. Okay? This is the channeling of the water. If we had a good cement job, this is not happening.
So the thing
But-
is, it's not the channel that causes the damage.
But if you have a bad cementing job, bad cementing material, maybe have a channeling of the water and damage the casing. Another type, I think in the European formation, this problem, maybe we have an earthquake and moving a formation tight and collapse the casing.
Okay.
This is another type. This two type is about the outer diameter, but during the production.
But before we go to the production, how can we? Okay, have you like experienced it with the earthquake, the damage to collapse the casing, in your experience?
Yes, in the Iran we have a field. We have a field after the earthquake because we have a salty formation.
Okay.
Salty formation. Salt formation is very movable. With the earthquake, move to collapse the casing.
So it happens only in one well or in each well?
No, one well. In the one well.
One well only.
Only one well. After this, we plug the well.
Okay.
Not remedial action because the very bad problem. Just plug, inject a cement and abandon the well.
Kill the well, yes.
Kill the well.
We don't need it.
Because all of the casing collapsed. We cannot use any mitigation, any remedial action to solve this problem.